welcome back to the Real Number System. Today, we're going to be looking at section 3.3 and talking about subtraction of whole numbers. We'll talk about what it means to subtract numbers. We'll talk about subtraction algorithms. We'll talk about models. We'll talk about how to subtract with bases other than 10. And we'll also talk about our mental computational skills. Let's get started. Operations that undo each other are called inverse operations. Addition and subtraction undo each other, so these two are inverse operations. Now we can model subtraction in several ways. Our first model is called the takeaway model. The takeaway model literally thinks about taking away some items. In our first example, suppose Caleb has 6 blocks in one pile, and he gives 4 of those blocks to Juan. How many blocks does he have left? We're going to use the takeaway model to illustrate the subtraction here. So first, draw a set that has 6 blocks. I want to take away 4 blocks to show the 4 blocks that Caleb is giving to Juan. So notice I draw a circle or a box around those 4 blocks to show that I am taking away those 4 blocks. There are 2 blocks left in our set, so 6 minus 4 is 2. Let's look at another example. Alicia has 7 cupcakes. She gives 4 cupcakes to her friends. How many cupcakes does she have left? Again, we're going to use the takeaway model to illustrate our subtraction. Draw a set that has 7 cupcakes. I use dots here to represent the cupcakes. Alicia is going to take away or give 4 cupcakes to her friends. So I'm going to box in 4 cupcakes to show that I'm taking away those 4 cupcakes. There are 3 cupcakes left in the set. So 7 minus 4 is 3. Our next model is called the number line or the measurement model. With subtraction, we'll show an arrow moving to the left to show the number that we are subtracting. Kaya walks 9 miles. She walked 5 miles before lunch. How many miles does she walk after lunch? Let's use the number line model to illustrate the subtraction here. Now typically when I draw a number line, I'm going to draw a number line from 0 to 10. Notice that Kaya walked a total of 9 miles. So for my first arrow, I start at 0 and I jump to 9 to represent that total of 9 miles. She walked 5 miles before lunch, and I want to know how many miles did she walk after lunch. So I'm subtracting the 5. I'm going to draw an arrow to the left that goes back 1, 2, 3, 4, 5 places. And so 9 minus 5 is 4. In our next example, Thomas drives 6 miles to school. If he's already driven 4 miles, how much further must he drive? Again, we're going to use the number line model to illustrate our subtraction. Draw your number line, and I typically count from 0 to about 10 on my number line. Thomas drives a total of 6 miles, so I draw an arrow that starts at 0 and jumps to 6. He's already driven 4 miles, and I want to know how much is left, so I'm subtracting. I'm going to draw an arrow to the left, 1, 2, 3, 4 places. So 6 minus 4 is 2. Our next model is called the missing addend model. In this model, we are relating addition and subtraction. So you'll notice here that we have 3 blocks in the set, and I want to know how many more blocks are needed to make a total of 8. Or on my number line, I've already jumped 3. I want to know how many more places I have to jump to make a total of 8. So 8 minus 3 is 5, if and only if 3 plus 5 is 8. This gives us our relationship between addition and subtraction. When I have 8 minus 3, this can be thought of as the number of blocks that must be added to 3 in order to get 8. In other words, the number 8 minus 3 is that missing addend in our equation 3 plus question equals 8. Suppose Isaiah has $4. He wants to buy a toy that costs $9. How much more money does he need? We'll use the missing addend model to illustrate the subtraction here. So 4 plus what equals 9? Well, 4 plus 5 is 9. Suppose Sarah needs 7 ribbons to finish her project. She has 6 ribbons. How many more ribbons does she need? Again, we'll use the missing addend model to illustrate our subtraction here. So 6 plus what equals 7? Well, 6 plus 1 equals 7. Our last model is our comparison model, which compares two quantities. One has 8 blocks, and Susan has 3 blocks. How many more blocks does one have than Susan? For our comparison model, we'll start by drawing 8 blocks for Juan. Then I'll draw 3 blocks for Susan. Notice that Juan has 5 more blocks than Susan. So 8 minus 3 is 5. Robert has 9 toy cars. And you'll notice here that I've drawn 9 dots to represent the 9 toy cars. Tyson has 6 toy cars. So I draw 6 dots to represent the 6 toy cars that Tyson has. How many more cars does Robert have? So notice that Robert has 3 more cars. So 9 minus 6 is 3. Now we've already talked a little bit about this definition of subtraction when we talked about that missing addend model. A minus B is a unique whole number C, such that B plus C equals A. Now notice that the first number is going to be bigger for our whole numbers. A fact family is a group of related facts using the same numbers. So suppose we have 4, 7, and 11. Our first fact would be 4 plus 7 equals 11. Another fact would be 7 plus 4 equals 11. I use the commutative property of addition. Now I can continue my fact family with subtraction. 11 minus 4 equals 7. Or I could say 11 minus 7 equals 4. Our fact family for 5, 3, and 8 would look like this. 5 plus 3 equals 8. 3 plus 5 equals 8. 8 minus 5 equals 3. 8 minus 3 equals 5. This brings us to our properties of subtraction, but a word of warning first. If I'm talking about 3 minus 5, you know from algebra that 3 minus 5 is negative 2. Using our definition of subtraction, 3 minus 5 equals C, some number, if and only if I can use addition to get 3. So in other words, what number plus 5 gives me 3? Well, there's not a whole number plus 5 that equals 3. So 3 minus 5 doesn't really mean anything in our set of whole numbers. However, never tell a student that it's not possible to subtract 3 minus 5. It is. Again, you know from algebra that 3 minus 5 is negative 2 when we bring in our integers. It's just not possible in the whole numbers. If you ever tell your students that something is not possible when it is, just with information they don't have yet, that's going to make it harder for them to accept the new information when they get to it. So instead of telling students that the bigger number always comes first with subtraction, tell them that for right now, our bigger number comes first. Let's talk about some properties and whether or not they hold for our whole numbers. And again, we're thinking about the operation of subtraction. Now, we just talked about the closure property. 3 minus 5 is negative 2. This is not a whole number. And so that tells me that the closure property does not hold for subtraction. What about the associative property? If you remember, our associative property changes the grouping. So let's look at some changes in grouping. Let's suppose I have 5 minus 3, quantity, minus 2. I want to know if that's equal to 5 minus, and then I have the quantity 3 minus 2. So notice I've changed the numbers that are grouped together. I'm going to put a question mark over my equal sign because I'm trying to decide if these are equal to each other. We start with our parentheses. So 5 minus 3 is 2, and 2 minus 2 is 0. On the right side of our equation, 5 minus, bring down, and then 3 minus 2 is 1. So 5 minus 1 is 4. These are not equal, and so our associative property does not hold. Well, let's talk about the commutative property. Commutative property, remember, changes our order. So I want to know, is 5 minus 3 the same thing as 3 minus 5? Well, notice I put a question mark over my equal. 5 minus 3 is 2, and 3 minus 5 is negative 2. These are not the same thing, and so the commutative property does not hold for subtraction. Finally, let's talk about the identity property. If you remember from section 3.2, 0 was our identity for addition, because 0 plus 5 is 5, or I could say 5 plus 0 is 5, and 0 is that identity because when I add it to anything, I get that anything that I started with. So let's see if this holds for subtraction. Well, 6 minus 0 is 6. We're off to a great start. But with the identity property, I also have to reverse the order and still get 6. But 0 minus 6 is not 6. It's negative 6. And so here, our identity property does not hold for subtraction of whole numbers. In our next video, we'll talk about algorithms for subtraction, we'll talk about subtraction in bases other than 10, and we'll talk about mental computation.